Astronomers have opened a stunning new window on the universe. As we peer ever deeper into space, we travel farther back in time.
This idea that we can map the universe and see its history is a testament to our imagination and our desire to explore.
How far away are these things? Are they little dwarfs nearby, or are they star-forming protogalactic subfragments? What are they?
Now to a distant horizon we venture, to the very brink of time and space. Its stars number 100 billion. It is so vast it takes 70,000 years for light to travel across its expanse. For more than 100 million centuries, it has defied the eternal night of space. Our Milky Way is but one galaxy out of billions of others. And yet, behind its luminous veil, amid the chaos of gas and stars, is a small wonder. Nine tiny planets united by little more than their orbits. In their embrace, a star of no particular distinction. Within their sphere, a world of singular importance.
But we're getting there.
As far as we know, our planet Earth is the one place in all the cosmos where creation has allowed itself a few admirers. Chief among them, the Garland family of Fort Worth, Texas.
Shelley and I first started coming out to the Davis Mountains when we were still in college, and we were first introduced to the mountains together. And the nighttime skies right out here at the state park.
15 years ago, Shelley and Don Garland helped organize what has become the largest gathering of stargazers on Earth. 150 miles from the lights of the nearest city, the Texas Star Party will take place under night skies as dark as any in the United States. For 6 nights each spring, up to 700 stargazers descend on this remote cattle ranch to roll out their telescopes.
Welcome to the Dust Bowl, the Texas Star Party.
They come geared up with precision mirrors and equatorial fork mounts, sophisticated computers and star tracking software. The sky's the limit.
This is the most exercise you get in the course of an evening, is taking the top off.
There's no hangover. I don't kill off brain cells. I'm with a great group of people. I can't think of a better thing to do.
The Ring Nebula, Jupiter, Venus, M13.
For the Garlands, the Star Party is part vacation, part pilgrimage. This trip marks an important rite of passage.
Yes!
Yeah!
10-year-old Ian has attended every year of his life. This year, he'll get his first telescope and take his place amid the community of amateur astronomers.
There's a lot of things out there that people never realize are out there. Just seeing these points up in the sky that don't really mean anything except they're just white dots. But there are all kinds of things out there that are just unbelievable to see.
As night approaches in West Texas, 1,000 eyes are at the ready. For stargazers around the world, the secrets of creation are emblazoned across the heavens. But even as the universe beckons us to explore, it also challenges us with its incomprehensible distances and staggering voids.
As we discover more and more, and the universe seemingly gets larger and larger, more complex, vaster, there's a tendency perhaps to think that humans' role in this diminishes with time. But for me anyway, it's like learning my world better. I feel larger the more I understand. I don't understand the purpose of it all at this point, but at least I begin to understand my place in it.
Today, the science of astronomy is being transformed by a new age of technological advances. On mountaintops around the world, scientists are opening ever larger telescopes, capturing light from ever more distant reaches of the universe. That light may have traveled millions, even billions of years to reach us. By the time it does, it offers a window into the distant past.
These giant telescopes, they are the only true time machines that human beings have. And they are totally faithful. There's nothing hokey about this. You look through a giant telescope, you get a view of a very distant region of space, and it is as though you were a historian and could put your eye to a telescope and actually see Hannibal crossing the Alps and all those elephants trotting along. We are actually seeing the universe and the things in it behaving as they did billions of years ago.
The deeper into space we peer, the farther back in time we venture. This notion that we can study the history of the cosmos is only a few decades old. Early in this century, astronomers believed that the universe was eternal, infinite, and unchanging. Our solar system, they found, is nestled within a flat, rotating disk we now know as our galaxy, the Milky Way. But they envisioned our galaxy as the whole of the cosmos. Beyond lay only the blackness of space. Albert Einstein, for one, defended this model of a static universe, but he recognized an implicit flaw. Gravity ought to cause stars and gas to collapse into a common center. Instead, he proposed an unknown repellent force somehow keeps them apart. This vision was about to be shattered. In 1917, after 15 years in construction, a powerful new telescope mounted on a summit above Pasadena, California, was opened. The Hooker telescope was hailed as a technological marvel. At 100 inches wide, its mirror was by far the largest ever built.
100 years ago, there was a feeling that if you just got enough money together and built a bigger telescope, then you'd see further and it would just be more of the same. What happened with the 100-inch telescope is that it was a lot more than just more of the same. In fact, it was a fundamental reappraisal of the nature of the universe.
Among the parade of astronomers, a young newcomer arrived fresh from service in World War I. Edwin Hubble was interested in mysterious cloud-like objects known as nebulae. He turned the new telescope on the fabled Andromeda Nebula.
Andromeda was very important to Hubble because astronomers were wondering what all these little fuzzy blobs that we now call galaxies were. And there were lots of astronomers who thought that they were small little things that were just pieces of the Milky Way. But Hubble was able to discover stars in Andromeda that he could see were very much like stars in our own galaxy. And at that point, everything clicked into place. He got the scale. He could see that it was far away. It was big. There was no way that it was a little piece of our own Milky Way.
Hubble discovered that the universe contains other galaxies, that it's far larger than we dared imagine. But he didn't stop there. He analyzed the light of distant galaxies and found that it skewed slightly to the red. This redshift is the result of the Doppler effect. It's like the sound of a train whistle that changes pitch as it speeds past. The redder the galaxy's light, the farther away it is, and the faster it's moving away from us. The universe, Hubble found, is not static, but expanding rapidly in all directions.
And it expands according to a very simple law, and I have a tiny piece of the universe here that shows that. So the black elastic here represents the stretching space of the universe, and these stars represent galaxies. So if I stretch the universe, the galaxies move apart. They recede from each other. The universe is expanding. And they recede from each other in such a way that the velocity is just proportional to their separation. So if I sit on this guy, this moves at some velocity, this at twice that, this at 3 times that. And it's the same for this guy. This guy moves at velocity v, 2v, 3v. Anywhere I sit, I see the same law.
The importance of Hubble's discovery eluded most of the world, but not one visitor.
Dr. Einstein, who gave the world its biggest headache, is back in California again with his wife. Now he is going to the Institute of Technology in Pasadena to work with other distinguished scientists.
In 1931, Einstein lent his prestige to Hubble's discovery. He conceded that his own model of the universe was wrong. It was not a repellent force that kept the universe from collapsing, only its relentless expansion. News traveled fast, all the way to Hubble's hometown paper in Missouri.
In my mind, there's no doubt that Hubble's discovery that the universe is expanding was the most important scientific discovery of this century. And the reason is that without an expanding universe, it's impossible to make sense of the idea that the universe has a finite age, that it came into being a finite time in the past.
This discovery had a profound consequence. If the universe is getting larger, we can make a movie, a cosmic movie, and we can run it backwards. It would look very comical. All the galaxies would be getting closer together, and we can see that the expansion of the universe implies that there was a first moment, a Big Bang.
All the universe can be traced back to a single explosive event. This idea launched the modern science of cosmology. Like Hubble before them, astronomers today place galaxies in time and space by measuring how far their light is shifted to the red. To understand the sheer scale of the universe, they are working to translate these readings to actual distances. Slowly, they are discerning the size and layout of the universe, one stolen glimpse at a time.
It's going to be a good night tonight. We're going to get something done. We're going to find out how big the universe is. We're going to find out what shape it is. We're going to find out what kind of shape we're in. It's going to be fun. Let's hope the equipment works. I always worry about the equipment.
Astronomer Robert Kirshner has come to Mount Hopkins in Arizona to study what may be an ideal mileage marker. A kind of star that goes out in a blaze of glory.
All right, this is going to be supernova 1996, number 13. And it's going to be record number 42 on the disk.
It is a supernova, an event so rare it happens only once a century in most galaxies.
We can see these things. They really exist. A single star becomes as bright as a billion stars, and that means you can see these things in distant galaxies. The whole star explodes suddenly, and you get a violent explosion, a nuclear explosion, in which the nuclear fuel, this carbon and oxygen, burns very, very rapidly in a kind of burning flame.
A supernova is a cosmic flare, providing a singular chance to measure the distance to its host galaxy. Kirshner can calculate how bright this type of supernova should be, so the dimmer one appears from Earth, the farther away it must be.
This is a picture that was taken while supernova 1994D was still bright. And so this is the supernova. It's a star in that galaxy that exploded. These things are so bright you can see them out halfway across the universe. That star isn't there anymore. And the light from it came to us, and we saw it a couple of years ago. That one is one...
Because the supernovae Kirshner is studying are so far away, they are dim indeed.
20? So the standard star is something like 20,000 counts in a minute, right? Yeah. What we're seeing for the object is something like 1 count per minute, roughly speaking, right? Something like that.
The telescope counts light particles. But by the time these photons reach us, precious few land on the telescope.
That's it. We should expect it to be that faint. Yeah. We should expect it to take forever.
After long hours of recording, the telescope at last captures its image.
Okay, here we go. Oh, look at that. A little streak down the middle.
It's better than the last one.
It's much better than the last one. All right. All right. All we have to do is do this for another 2 hours, and we'll have some kind of signal.
Gone are the days when professional astronomers huddled over their telescopes in the cold of night, painstakingly logging their findings. Today, computers do most of the work, leaving observers time to ponder. Once a distance scale is finally in hand, it can be applied to a much larger project, one astronomers pioneered in the 1980s to discover the very structure of the universe. It was long assumed that the Big Bang created a sprawl of galaxies spread uniformly across space. That it might instead have a more complex structure seized the imaginations of scientists. Among them, Margaret Geller.
Here's a nice
case.
You can ask lots of questions in science that you can't answer, either because the technology isn't there or because you just haven't defined it well enough. So if you ask, what does the universe look like? The universe is huge. So what are you going to do? I mean, you have to figure out how to map a little piece of it wisely chosen so that it will tell you something in answer to a very precisely defined question. It's hard to imagine.
We still have to,
that question for Geller and her colleagues was whether a narrow slice of the universe could reveal a pattern on the largest of scales. She set out to actually begin mapping the universe.
We mapped the distribution of galaxies in this first slice of the universe, not expecting to find pattern because the prejudice was the pattern wasn't there. And when we plotted the data, we saw this pattern, which has become very famous. It's known as the stick man. So here you can see that there's a very striking pattern. There are large empty regions where there are very few galaxies, and these regions are 150 million light years across. But most of the galaxies are in thin structures which surround or nearly surround these empty regions. And I must say that the experience of seeing this very striking stickman pattern was a kind of thrill that I think people are very fortunate to have once in their lives. And you just wonder why, how could it be that you are one of the first three people to see this?
ביום שישי, כוכבים במשכן, והשבוע להקת טיפקס ואורחים. ומאחורי הקלעים מיכל ינאי ושי אביבי. כוכבים במשכן, שישי 8:45, ערוץ 2, תל אביב. ביום שישי. חשבתם שהשליח הזה יביא לכם פיצה? טעיתם, הוא מביא צרות.
Who the fuck are you? I told you my name's Chili Palmer. Look at me. Look at me.
What? ג'ון טרבולטה. רנה רוסו וג'ין הקמן. תפוס את שורטי, שישי 9:50, סינמה 2, תל אביב. כמעט 50, מבט מקרוב על החברה הישראלית. תקשורת עם אילנה דיין. תרבות הפנאי עם רזי ברקאי. ספורט עם יורם ארבל ואריה מליניאק. צרכנות עם מיכה פרידמן. איך אנו נראים במדינה בת כמעט 50, ספטמבר בכל יום רביעי 10:20, ערוץ 2, תל אביב. אנחנו חיים בעולם משתנה.
וואו, וזה טוב?
זה לא נורא שינויים.
באמת? מה זאת אומרת?
זאת אומרת ששינויים זה טוב מאוד.
מה? תסבירים בבקשה.
ימי השידור מתחלפים.
הבנתי. ומה עכשיו?
עכשיו תלעד עוברת לראשון ורביעי.
אומייגאד, תפסיק להיות דרמטי.
שכחנו משהו? כן.
מתי זה קורה?
זה קורה ב3 בספטמבר.
עובדה.
קיץ חם בתל אביב.
Geller's first wedge extended roughly 700 million light years into space and contained 1,000 galaxies. They skirt the perimeter of vast, empty spaces, which she likens to bubbles. But is the pattern in Geller's slice a fluke or a phenomenon? She set her sights even farther afield. Now, more than 7 times the galaxies are plotted over a wider area. They are drawn in expansive sheets of matter that encircle enormous voids.
I think that there is some kind of fundamental human attraction to patterns in nature. Many times when I've given public lectures, especially to young people, I ask them whether they would prefer, suppose they could design the universe any way they wanted, how would they stick galaxies around in the universe, they just throw them out like grains of salt, or would they make a pattern? And every single audience I've ever talked to, they all want to make a pattern.
How did the universe gain such definition? The answer is written in microwave radiation that bathes the Earth from all directions, the afterglow of the Big Bang. There were slight variations in the density of the primordial gas. Over time, gravity amplified them and drew matter into a vast web. Cosmologists are using their newest tool, the supercomputer, to envision how the universe then evolved. Out of patches of stars and gas, galaxies began to coalesce. While the universe as a whole expanded, gravity held these evolving star systems in clusters. Some merged or were swallowed by others. To this day, violent duels continue to erupt between galaxies. Their immense gravity sets them on a collision course. They cross paths, leaving behind vast trails of stars and gas to mark the encounter. Aftermath, whole new galaxies emerge.
So this is about the size of the bright region of the galaxy.
That's right.
It's amazing. Gives you some idea of what a fun...
Margaret Geller is now part of an international effort to map galaxies in ever larger portions of the universe.
And then
move them on.
For her, the task will be that much easier thanks to an instrument that will be attached to the base of a telescope.
Place on the galaxies.
A pair of robots will deploy 300 fiber optic sensors. Each sensor will capture the light of a single galaxy, then move on to another. They'll capture thousands each night, 100,000 per year. The robots, light on their feet, are nicknamed Fred and Ginger.
We'll pretend to be a hectospec robot.
Yeah.
You can be Ginger. I'll be Fred.
Okay. Well, a lot less graceful than Ginger. I could barely reach this thing.
I'll put that one on.
Geller believes that with technology advancing at its present rate, new generations of astronomers will have mapped the entire visible universe by the end of the next century.
This idea that we can map the universe and see its history is a testament to our imagination and our desire to explore. It's these things that really make us human. It's an extraordinary thing that we can ask these questions about our grandest environment, and I think it's even more extraordinary that we can answer them.
The telescope that will house Geller's instrument is itself a milestone. Construction at the University of Arizona began with tons of glass, melted, then spun into shape. After months of polishing, workers are now mounting a strategic attack on a few remaining imperfections, specks of dirt. precision tools, a box of toothpicks, and some solvent. Bound from Mount Hopkins, this is one of the largest optical mirrors in existence. But even the best ground telescopes are at a disadvantage. As far as the light of the universe has traveled to reach us, its way is blocked in its final mile by the blurring effects of our atmosphere. We are learning to cancel these distortions with computers and sophisticated optics. Astronomers are now realizing an even loftier ambition. To capture the pristine light of the universe with a telescope positioned in space. In 1990, astronauts placed the Hubble Space Telescope in orbit 200 miles above the Earth. Its mirror was designed to produce images 100 times sharper than the best telescopes on the ground. Then disaster struck. A flaw in Hubble's optics impaired its vision. The world's astronomers despaired. The largest investment ever in astronomy, nearly $2 billion, seemed utterly lost in space. Astronauts returned to Hubble's side. The nation looked on as they undertook painstaking repairs against seemingly impossible odds. Within weeks, the suspense was rewarded with images of breathtaking clarity. Amid the rush of accomplishments, Hubble showed its true forte, capturing visions of galaxies deep in the universe.
As we look out in space, we look back in time. And today, with large telescopes on the ground and with space telescope, we can look at galaxies as they were 5 billion, even 10 billion years ago. Very near, galaxies which are very young. And we can see, in fact, we can measure from the ground how galaxies were distributed. So the historical record is there for us to observe.
The Hubble Space Telescope is probing regions billions of light years away, when the universe was far younger than it is today. There, galaxies have blotchy, distorted shapes. They are pocked with the bright blue signature of myriad stars being born.
One of the most exciting things about these really distant galaxies is that they look quite different from nearby galaxies. They look very disturbed, very irregular. And then there are all these little specks, tiny specks and blobs that don't look anything like galaxies nearby. Those are probably the little bits and pieces, the little building blocks, the little galactic Lego pieces out of which galaxies were forming at a very early time.
Today, astronomers are using Hubble to extend the very limits of what we can see. Mark Dickinson studies the origins of galaxies.
It's a great time to be an astronomer because you have new tools like the Hubble Space Telescope to study extremely faint objects which can't really be probed in any other way.
Dickinson led one of Hubble's first projects after the repair. He and colleagues discovered a group of galaxies 8 billion light-years away. It was, for a time, the most distant cluster ever glimpsed.
He took us to the airport.
Now, he is part of an ambitious new venture known as the Hubble Deep Field. The project will zero in on a tiny patch of sky near the Big Dipper that is no larger than a grain of sand held at arm's length. To most ground-based telescopes, the target area appears utterly void of galaxies or stars.
The idea of this project is to go as deep and faint as the telescope can be pushed to go and see the faintest galaxies. Those don't even show up in individual exposures for the most part. They're so faint that there's not enough light for them to record an adequate signal on one exposure. But this is one of 50 or so that we'll be taking through, say, this one particular filter over the course of 10 days.
That's a galaxy. Do you always display it linear as opposed to, have you tried log or square?
The project has drawn a team of astronomers from around the world. Already, images of distant galaxies are beginning to take shape.
This one I would have thought is a spiral.
Yes, but it has no nucleus and or several or extra.
They're counting on this venture to shed light on how the universe and its galaxies evolved from the earliest times.
Bringing up both the faint stuff without.
It would be hard to imagine a galaxy would end up looking like that.
The question is, just how deep in the universe has Hubble delivered them?
That is really a great part of the field.
Now we can build bigger and bigger telescopes and see even farther out into space. And the limits of how far we can see galaxies now are about 10 or maybe 14 billion light years. This is assuming that the universe as a whole is about 15 billion years old. So the farthest we could see is 15 billion years, because that's all the time that light has had to travel. And that's the edge of our visible patch. It's called our horizon.
For now, it seems, Hubble's view of that horizon is obscured.
Some things change from exposure to exposure, which are all the cosmic rays. And by filtering, by comparing at a given position and throwing away anything that strongly deviates, you remove the cosmic rays and end up with a combined image that looks like this. And that's the basic cleaning process that we do.
Scatter light getting into the telescope.
Then there's glare from the sun.
We're going to try subtracting out these patterns independently.
At last, the team begins its major work to enhance details within the galaxies.
Much better now.
They repeatedly shift Hubble's position slightly off-center. In the coming days, they'll overlay the varying images and refine them pixel by pixel.
But I think they'll go.
I take one picture like this, shift a millimeter, take it again, shift a millimeter, take it again. So I'm taking the same picture, but it's slightly different positions, so I get a better sample.
If you've ever,
and then you combine the information from all of that, and you get a better resolution. Is that sort of roughly right?
Right. If you've ever watched on television when they black out someone's face, they put on these large pixel squares. And we have something like that. We have a face blocked out by large pixel squares. And if someone gave you the original videotape with those large pixel squares, you could, using a technique like this, reconstruct that person's face.
Barely a month after the Hubble Deep Field began, it's time for the big unveiling. Astronomical Society has brought a series of extraordinary revelations. This year, the deep field is center stage.
So let's stand across the sky.
It's an hour before curtain, What better time to address an important question? How many galaxies are there in the universe?
I like the 100 billion, because it's like roughly the number of stars in the galaxy. But I think we better not push our catalog verbally too far.
It boils down to simple math. Take the number of galaxies in the deep field and multiply across the full extent of the sky, give or take a few billion.
So we're talking about 50 billion across the sky, roughly.
The winning number? 50 billion galaxies.
This is a large blow-up of it done by a photographic lab, in which you see very small region of the sky, 10 days of exposures, and you can see a myriad of galaxies. There are roughly 1,500 of them.
As Bob described, this is a basically blank patch of the sky, which if you look at it with a modest-sized ground-based telescope at one of the sky survey prints, you see almost nothing, 1 or 2 galaxies. The statistics, the sheer numbers are impressive, but by itself, that's not really enough. We can count the galaxies in this image and say, my God, there's a lot of them, but we don't know what they are. We need to understand what these galaxies are. We need to understand how far away they are, what their properties are, before we learn anything about galaxy evolution from a picture like this.
Revealed in stunning detail, the distant frontiers of time and space. The early universe, it seems, is a jumble of twisted shapes and cosmic question marks. The deep field is simply a flat portrait. Which of these galaxies, astronomers want to know, shine from the limits of the visible universe? And what milestones in galaxy formation do their shapes reveal?
In many ways, what we have here is an archaeological dig, the deepest archaeological dig ever done. And we're left with a good view of the colors, the shapes, the sizes of all the relics, but we don't know the layer of dirt from which they came.
How far away are these things? Are they little dwarfs nearby? Are they star-forming protogalactic subfragments? What are they? Well, we'll try to find out eventually, and that's what this is meant to be a resource for.
For all the unknowns the deep field presents to astronomers, to the public, it's sure to be a revelation.
I think it's one of the most important things that the Hubble is doing. The picture is stunning, and we'll probably want to run that and then await the scientific analysis and then report on that.
Huge numbers here, billions of light years away, billions of years ago, billions of 100 millions of light years across, seeing things I've never seen before. This is easy. This is like candy to a science writer. This is easy. This is like falling off a log.
The deep field goes on view like a grand work of art snatched from space. Measuring the distance to its galaxies, the same work that once consumed Edwin Hubble now awaits astronomers lining up to study it. They will peer for the first time into this narrow celestial corridor. Hawaii's Mauna Kea volcano is one of the largest and most sophisticated telescopes on Earth, the Keck Observatory. Tonight, a group of astronomers has come to pinpoint the most distant galaxies in the deep field.
It'll be 5 minutes. Okay.
Sandy Faber leads the team.
So you're gonna...
My own personal hope for the Hubble Deep Field is to identify the moment of the beginning of galaxy formation. What were the first proto-galaxies like? How big were they? How did the stars form in them? We're looking back to an era when the universe and the galaxies in it were really quite different from the ones we see today. But not totally different. We can see a relationship. These are infant galaxies and adolescent galaxies compared to our own mature galaxy today.
Faber and her team are looking for galaxies 10 to 15 billion light years away. These appear as tiny blue lights in the deep field, shining faintly among the larger, brighter ones. To capture the light of these distant gems, they'll isolate them in a series of slits.
These labels tell us what to expect if we're lucky, and everything that says HZ means very high redshift object. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 possible very high redshift candidates on this mask, which makes it an exceptionally rich mask for very, very distant galaxies.
Keck is one of the most complex instruments in all astronomy, but rarely has it been pushed this far. Ed Groth is one of Faber's collaborators.
It's wonderful. I just can't believe that I get to come up here and use it. It's really a rush.
Still, Keck is only 3 years old, and it has a few kinks.
We think that this particular grading setting is an optimum for finding our high redshift distant galaxies. Which way is our compass rose? It says that we're
at minus.
See, I'm a little bit irritated at the quality of those images.
Yeah.
I don't think that's a wonderful image. Yeah, it's not. That ain't wonderful. That looks like telescope.
Inevitably, time is lost to calibrating the telescope.
That ain't good. At Keck, we're at 14,000 feet. We don't think very well at that altitude.
That's one.
Every moment of telescope time is precious. You prepare intensively to go there. It's easy to make a mistake and waste time during the run that you have. It's just like a time warp. It's living very, very intensely for a short period of time. It's thrilling, really.
We've got the offset applied. Wait for a few seconds. Okay, start the exposure.
Wow, Drew, that's our best alignment yet. Every star's in the middle of the box.
And the star images look pretty good, too.
Each of these galaxies is 100 million times fainter than you can see with your naked eye. And they're hard even for this big telescope.
At last, Keck captures its first flickers of success. The spectral barcodes of these galaxies hardly seem as impressive as Hubble's pictures, but to the trained eye, they're nothing short of sensational.
There's a really nice continuum in that object there.
Here, you can also see one here. I'm running the cursor along it.
Yeah, I see that.
That's correct.
Okay.
What about there?
Ah, yes. Because see, we saw something.
Yeah, exactly.
That's it. That's it.
All right. Looks good.
In the span of a few nights, Faber and her team record no less than 3 new high redshift galaxies. Each is fully 90% of the way back to the edge of the universe.
We've discovered a couple of new, really very distant galaxies in the Hubble Deep Field. We've probably got 3 or 4 redshifts above a redshift of 3, which means that we're looking back maybe 12, 13, 14 billion years. So those are among the top record holders. That's what we were really after in that field, was more like that.
As we peer ever deeper into space, how long before physical law itself blocks our vision beyond?
We know that there is a boundary to the universe that we can see. We call it the observable universe. It's how far a light ray can have gone since the beginning of time. We think that that observable universe is embedded in a much, much larger universe upon which we can make no observations because of the finite speed of light.
My response to the universe is complicated now, and it's really determined by the fact that I personally, not for scientific reasons completely, partly emotionally, think that there are lots of universes. I think that they might all be mostly different in terms of their physics from our universe. I'm thinking now of our universe the way other cultures might have thought about the nourishing Mother Earth. And in some sense, we truly belong here because we were produced by the physics here.
The universe is expanding relentlessly, but not too fast for a father to share its wonders with his son. The Texas Star Party is in full swing. Don Garland built this telescope for 10-year-old Ian.
We'll slip this right in there. Which way does this need to face?
Tonight, at their 10th Star Party together, they are ready to give it a test run. It may not be Keck, it may not be an orbit, but for a young astronomer, it's state-of-the-art.
What do you want? Say right up here? Yeah. All right. There you go. And just push in. Got it. You want to look at Venus first?
Yeah, where is
Since it's up?
Oh, there it is.
It's right there. To find it. Guess what? There it is. Oh, what a great view. Yeah.
I see.
All right.
It's my telescope. Oh, wow.
First object viewed astronomically through the telescope is Venus.
It's a rainbow, all right.
Yep.
Ian has a long life of stargazing before him, but tonight will be hard to beat.
It's definitely a...
When I see gas clouds, I see these little globules of stuff up there. What I think of is, you know, I'm seeing something forming. I'm seeing something being created. It's exciting.
Sometimes very mysterious to people and very frightening. And I know the Lord put things up there for us to see and to behold the beauty in it. And you can come out here at night and the ground is lit, that you can see your shadow and you walk around. And you can look up and watch the meteorites as they come in and just watch the heavens as they turn, which is a wonderful thing.
Not a religious person, but I have found piecing together the history of the universe and watching other people do it, trying to understand what they say about it, a very deeply satisfying experience. I think it just pleases me to know what the past was like, how I got here, and what the future is likely to be like. And I think this knowledge is important for me to decide where I fit into the big picture.
Where are you going, Jimmy? You want to see the light? Says, Dad, I know you saw something in there.
Tonight, even 2-year-old Jenny is starstruck, though her technique could use a little work.
What do you think? Did you see it? I doubt it, but you could try. You want to try again?
By the time she reaches her father's age, who knows what visions of the heavens await
Pretty
us.
cool. He wants to get in on it, too.
We once defined our universe only by the stars that turned overhead. Technology has now delivered us into a vast assemblage of 50 billion galaxies. As we continue to probe the limits of the cosmos, we can only hope our imaginations keep pace.